The James Webb Space Telescope has once again captivated the world with a breathtaking discovery. During a recent observation that sparked excitement throughout the scientific community, the telescope captured evidence of what seems to be a distinct, separate universe, strikingly different from anything previously observed. This astonishing finding follows closely on the heels of the telescope's earlier deep-field images, which had already pushed the boundaries of our cosmic knowledge. Now, what was once thought to be the outer limit of the known universe has been shattered, revealing a discovery that challenges not only astronomy, but also our fundamental grasp of physics, time, and existence itself. The breakthrough began with a routine deep space scan of a seemingly unremarkable region. The Webb team, using its advanced near-infrared instruments, was gathering data to address gaps left by earlier missions. However, what the telescope revealed was far from ordinary, not just another distant galaxy or a clearer view of familiar celestial objects. Instead, the data showed a region where light bent in strange, mathematically perplexing ways, with signatures that didn't align with any known cosmic phenomena. Further analysis uncovered structures that were too ancient, too massive, and too dense to fit within our current understanding of the universe. In the days that followed, astronomers intensified their study of this enigmatic region. Spectral data, redshift measurements, and gravitational lensing patterns led to a startling conclusion: this wasn't part of our universe. It behaved as if governed by an entirely different set of physical laws. Time flowed differently, light scattered in unfamiliar ways, and gravity warped in unprecedented patterns. What they observed was a self-contained realm, a pocket reality, operating independently of everything we thought we understood. This discovery overturns the established cosmological framework. The prevailing model, known as the lambda-CDM model, which accounts for dark energy, dark matter, and cosmic inflation, assumes a single, expanding universe born from the Big Bang. Yet, the James Webb Telescope appears to have uncovered a spacetime, an environment that is either entirely isolated or the result of a distinct cosmic event, perhaps another Big Bang or something even stranger. Theoretical physicists were sent into a whirlwind of excitement. The concept of a multiverse, once confined to speculative quantum theory and philosophical discussions, now has tangible evidence to support it. If this is indeed another universe, it suggests our cosmos is not unique. There could be countless others, millions, billions, or even infinite realities, each with its own physical laws, timelines, and possibilities. This isn't just a new point on the cosmic map. It's a gateway to an entirely new way of understanding reality. The visual data is spellbinding. Images reveal vast regions resembling galactic superclusters, but with peculiar color signatures that don't correspond to any known elements or structures in our universe. Where we'd expect specific hydrogen emission lines, we find unfamiliar frequencies. Stars emit radiation in ways that defy Planck's blackbody radiation curves. Some appear to burn without hydrogen fusion, and galaxies rotate without the influence of dark matter. Celestial mechanics at play seem to follow rules alien to our physics. Even more remarkable are the gravitational effects observed in this region. Light from background stars in our universe bends in ways that general relativity alone cannot explain. As if this other universe has its own gravitational field, yet exists outside our spatial continuum. This has led to the hypothesis that the two realities may overlap in a higher dimensional space, like two soap bubbles touching at their edges in a dimension beyond our perception. The James Webb images may be capturing this point of contact, raising profound questions: could matter, energy, or information transfer between universes? Is this interaction stable or fleeting? More unsettling is the possibility that our universe isn't the primary one, nor that the concept of a primary universe is meaningless. If multiple universes exist, they might form an infinite fractal, self-sustaining multiversal sea, each bubble spawning others through cosmic events we can't yet comprehend. Quantum mechanics, often at odds with general relativity, suddenly finds new relevance. The idea that particles exist in superposition, or that observation collapses wave functions, may now carry broader significance. If other universes exist with different outcomes, we could be looking at a vast, interconnected web of probabilities on a scale far beyond what the Copenhagen or many worlds interpretations ever envisioned. In the wake of the Webb data, supercomputers have been redirected to explore these implications. Simulations suggest that a universe with altered constants, say, a weaker strong nuclear force or a different speed of light, could still support complexity. Even life, though radically different from ours. These models open up astonishing possibilities, universes where stars never form but life thrives in cold gas clouds, realms where time loops, or regions where consciousness arises from magnetic fields rather than neural networks. The cultural impact is equally profound. For centuries, humanity has gazed at the stars and asked, are we alone? The question was always framed in terms of extraterrestrial life, aliens, or civilizations on distant planets. But this discovery shifts the paradigm entirely. We may not only share our universe with others, but share existence itself with countless realities. The notion that reality is plural, not singular, reshapes not just science, but philosophy, theology, our sense of what it means to exist. The alternate universe's structure is both chaotic and symmetrical. Unlike our own, which evolved from uniformity into the structured galaxies we see today, this other reality features wild clusters, twisted formations, and dense erratic energy fields. As if its creation followed an entirely different blueprint. Time and entropy might operate differently, perhaps even in reverse. Some physicists speculate this universe could be older or younger than ours, moving through time on a non-linear scale. Others propose it might be a mirror universe, dominated by antimatter, with time flowing backward relative to our frame of reference. If so, what we're seeing might not be a separate realm, but a cosmic reflection, twin echoing from the other side of a metaphysical mirror. The Webb telescope's instruments continue to refine the data, bringing this region into sharper focus. Artificial intelligence is now analyzing patterns, tracking anomalies, and comparing them to known cosmic behaviors. Early findings hint at possible technological signatures, regular emissions, repeating pulses, and geometric arrangements, sparking cautious excitement. While no one is claiming evidence of alien civilizations, the potential for non-natural phenomena has reignited. Debates long dormant in academia. This discovery also offers a potential solution to the fine-tuning problem. Why does our universe seem perfectly calibrated for life? If countless universes exist, each with different physical constants, our existence might be inevitable rather than miraculous, a cosmic lottery where every combination plays out somewhere. The finding also raises questions about our universe's origin and fate. If this is a junction between universes, it may not be unique. Countless rifts, bridges, or thresholds could exist across space, invisible until instruments like Webb uncover them. These portals might be remnants of ancient collisions, scars from the multiverse's early days, or active gateways sustained by forces we've yet to identify. From a scientific perspective, the data will take decades to fully analyze. Thousands of terabytes of high-resolution readings are being shared with research teams worldwide. This isn't a discovery to be shelved. It will redefine astronomy, cosmology, and particle physics for generations. Just as Galileo's telescope reshaped our cosmic perspective, Webb has shattered another barrier. Even in the first month of study, parallels are being drawn to abstract mathematical theories like brane cosmology, string theory landscapes, and loop quantum gravity, ideas once dismissed for lack of evidence, but now finding new relevance in classrooms. Coffee shops and beyond, the conversation has shifted. Children wonder if their counterparts exist in this other universe. Artists imagine skies lit by unfamiliar stars. Writers blend fact and fiction in stories that feel less like fantasy and more like foresight. The human imagination has been stretched anew, its boundaries redrawn by a telescope floating 1,000,000 miles away. This isn't just another astronomical milestone. It's a reminder of how vast the unknown remains. Every time we think we've reached the edge, the universe or universes proves us wrong. The James Webb Telescope hasn't just peered into the distant past. It has looked across a boundary that shouldn't exist and found something extraordinary. The cosmos holds secrets behind every veil of light, and with Webb we've torn through one more curtain, only to find another stage, awaiting a stage, where the rules are rewritten, the script unknown, and the possibilities endless.